Wash your hands, men. Metallic bonds. Metallic bonds are between a metal and a metal. Hence the name. Alright, so when you think of metallic bonds, you should think of a sea of electrons. So let's just draw, that's an ocean there, a sea of electrons. All the green are going to represent electrons. So the electrons make this sea. And then a cation, a metallic cation, is going to make up the rest of the water, which creates your metal. So all the things in orange are your metallic cations. Alright, so think of a sea of water. Let's get a cup of water. So let's just pretend that you put that water in this cup. Just one cup full. What would you think would happen to everything? The electrons would be able to move. So these dudes can just move anywhere they need to go. Usually, that would be wrong there, but this usually happens because of force, like crushing an aluminum can. So when you crush it, it doesn't break, it just bends. And it bends because these electrons can move. So if you were to write it out as actual symbols, you would see something a little more like this. It looks very organized, but any of these can move at any time. That's what makes metals malleable. Not sure how to spell it, but that's pretty close. Alright, so you should write this. Metals consist of closely packed cations in a sea of electrons. You should also write that all atoms share the electrons. So all these atoms, all these iron atoms, share all these electrons. The electrons, and remember the E- is just an abbreviation for electron. Electrons are not bound to one atom. And so when you have all these irons, so I went with iron here to show you irons with electrons, that creates a lattice. That's the structure name, a lattice. Alright, so let's go back over here to this definition that you wrote down. Metals consist of closely packed cations in a sea of electrons. So we know electrons are E-, but how do we know that we're getting these cations? And in this case, we went with, again, Fe+. So let's go to our periodic table. If you look at group 1, which are metals, alkali metals. First, I can draw this for you just to make it a little more clear. Everything to the left of these here are metals. So all this stuff, including these, are metals. Alright, so group 1, oxidation number for group 1 is a +1. Oxidation number for group 2 is a +2. Metals are going to stay consistent. They're always going to be positive, every time. So, this iron right here has multiple oxidation numbers. But, no matter what, it is going to be an Fe+. Now, it could be Fe2+. Or 3+, or so on, but in this example, we used a cation, which just means a positive, and that was iron plus. let's go back to your periodic table for just a second so that I can help you with a question on one of your practice problems. So, transition metals, all these dudes, can form multiple ions because they have multiple oxidation numbers. So, when it's actually written out, you might see iron 3 oxide. So, that just automatically tells you when you see these parentheses with the Roman numerals that iron specifically is going to have a 3+ charge. If it said iron 2, it is going to be Fe2+. So these Roman numerals always tell you the charge.